Hi there, this is Srikanth Dasari. So in this lesson, we are going to learn about how to add a node at the very end of the linked list. Okay. So in the last couple of lessons, we have dedicated our study how to create a single linked list and how to add a node at the very beginning of the linked list. Okay. So if you go to this is my YouTube channel, Dasari Tuts here. Okay. So we go to playlist section here. So we'll scroll a bit here and you will find a dedicated playlist for data structures here. Okay. So in that we have all kinds of topics and tutorials on data structures here. So stack data structure using structures and so on and so forth. So here we are in our seventh. This is going to be the seventh tutorial. And the fifth tutorial is the starting of linked lists here. Okay. So creating a single linked list and adding a node at the very beginning of the linked list. Okay. So let me launch the IDE here very quickly. So already I have created a project under the name single linked list here, and it consists of a source.c file here. Okay, so all the code I have inserted until now, what we have done here. Okay, so if you observe the menu in the choice menu choice here in the main menu. So if you run the application until now, so it has all the previous options which we have learned here. Okay, so added the beginning. So I have just added this added the end functionality. So for which we need to write the code here, and then we have a display linked list just to display the linked list, and the last but not the least, just to exit out the from the execution here. We have the exit function here. So if you check the functionalities until now, take the option one, it asks us to add the elements. We keep on adding some 5 elements like this, so 4 and 5. Now if you take a display list here, the third option here, so you get all the elements displayed here, 5, 4, 3, 2, 1, and so on and so forth. And if you take the option 2, nothing happens because we haven't written the code for that. Let's come out of the execution here. Okay, so here in the case 2, we need to write a function to add at the end here. Okay, so already we have added the beginning here, functionality function which is defined here outside the main function, and also we have the function for display. Now we need to write the code for add at the end. Okay, so for that let's start writing the code. We go to full screen here. Okay, so int add at sorry add at end. Okay, so just taking a function definition. Let's make some room for ourselves here. Let's go to scroll a bit up. Okay, so now first we need to take define a new node such that here our sole purpose is to create a node first and some allocate some memory to that. So before that, new node is equal to. So new node is equal to. We need to do with the syntax of malloc. Before that, we need to cast it using the node structure here. Okay. So malloc size of node. Okay. Size of not just node. We need to add a struct node here. Okay. So here we have created and allocated memory for our node such that a node structure is built in our memory with the data part and address part automatically allocated to that, because our structure comprises of both the data part and the next part for the address, storing the address of the next node here. Okay, so now we need to allocate we need to empty the address part of our newly created node here with the null pointer. Okay, so if you made it null, nothing does not contain any data. So, okay, the nodes are supposed to contain just the address of the next node. Okay, so here our intention is to add the node at the very end of the list, so it need not contain any address. Okay, just so here we can judge. We can go to the end of the linked list by tracking the null pointer here. Okay, so that's the reason we have made the last node as null as soon as we created the node here. Okay, so and then we need to so enter some data item here. So to store into that, I'm just putting that message. Enter the data item. So just a small message here, and let's put a scanf statement. So percentage %d ampersand new node of new node of data. Okay, So whatever the data part, so whatever the element you enter to the keyboard is the scanf function goes to the data part of that node here. Okay. So before diving into the linked list and adding the node at the ending, so first we need to check whether whether there are any nodes existing in the linked list. Okay. So further, there may be a condition that so if head is still null, that means that there are no nodes in our linked list here. Okay. So there are no nodes in our linked list. So then we need to make our the very first node as our head node here. Okay. So very first or the very newly created node as the head node. Okay. So return 1 to come out of this condition. Okay. So if it's that's not the case, so then what we need to do is we need to take the head node as the temp node here. Okay. So temp, we need to create another node here. Okay, if that's not the case, we need to take a while loop with the help of while loop. Whether you put it in the else condition or not, that does not matter to you. Okay, so first we need to create a temp node at the very beginning, which we haven't done here. Let's do it then. Let's say start temp here. Okay, so the temp node holds the address. The temp node holds the address of the head node here. Okay, so temp is equal to head, and then we need to take the while loop while temp of next not equal to null. So until it's not null, so we need to traverse the loop. Okay, so temp is equal to temp next. Okay, so temp is equal to temp next. So we need to traverse until the end of the linked list, until that part. Okay, so until that part, and then as soon as we go to the reach the end, so we need to make the temp next part, the address in the address of the temp next part, the temp next part, we need to add our new node. Okay, so this is the small source code for adding a node at the very ending of the linked list. Okay, so now what we have to do is we need to call this int add at the end function here. Okay, so int add at the end function here at the very case 2 here. Okay, so add at end, if I'm not wrong, without any arguments, add at end. That's what we have taken. Okay, so now so we are done with our coding. Let's run the application until now. What happens? Let's see. Okay, there is something missing here. Okay, some part is missing. Once we have done mistake here, return 1, new node next is equal to, and let's take it a bit. Excuse. Okay, so now let's save and run the application once again here. Okay, so just a second. Okay, so let's save and run the application once again here. Okay, so with the help of our F5 function. Okay, it's run successfully. So let's add some data items here. So one, so let's keep on adding the data items until four to five data items here. Okay, so now if we take the display, so here we have 5, 4, 3, 2, 1 got displayed, since we are taking the option 1 here to add at the beginning. So now let's take option 2 add at the end here. So let's add some more elements, 2, 7, and so on and so forth. Okay, so now if we display the list, we have added the elements at the very ending using the option 2 here. Okay, so all these things has been made possible because we have defined a small function here with the help of add at the end definition here, and we have made the call to that function here inside our case here, case statement. Also, we have taken a switch choice at the beginning menu here. Okay, so we are just keeping on adding the functionalities, various functionalities which were bound to the data structure single linked list. Okay, so first we have done in the very first lesson, say which is single linked list 1. If I am not wrong, we have just created a single linked list at that time, and then we have added the node at the very beginning in the second operation, which is with the help of this add the beginning functionality, and then we have taken added the end option sorry, function. So and then we have put some code. So if you revise the code once again, we have just taken two pointers to our node structure here. For this new node, and the other one is temporary node. The new node, the duty of the new node is to allocate, create a new node, which is going to be added at the very end of the linked list, and then we have taken using the scanf function, we have taken some data item here. Okay, so and then what you have done is so here we are checking whether the head node is still null, which means that there are no nodes in our linked list. Our linked list is empty. So then there is no case in point of adding the node at the very end of the linked list. Okay, so only adding the node at the very end of the linked list is possible if there are some elements existing in the linked list. Okay, so if there are no nodes in the linked list, the very first node, whatever we are creating itself becomes the first node, the very first node of the linked list. Okay, so that's it. That itself becomes the only existing node. So that's the reason we are making the newly created new node as head node. Okay, so by assigning the address of the new node into the head part, so we get this functionality here. Okay, so if that is not the case, so we are taking another temporary pointer and assigning the address of the head node, and we are traversing until the head node is not null here. Okay, until the head node or indirectly the temp node here, until it's not null, we are traversing until the last node of the already existing linked list here. Okay, so if you go to output once again, so if you keep on adding some elements here, let's say 5, let's add some elements, 5, 4, 3, 2, and 1. Okay, so let's say display. So here we have 5 elements here. So with the help of our in the code, if you go to so if you scan the code here, okay, so if you scan the code, so in this while loop, we are saying temp is equal to temp next. So according to our output, which we have got here by taking the add at the beginning option here. Okay, so we are traversing until the fifth data item, the fifth, which is the fifth node in our single linked list. So because the last node always consists of the null part here. Okay, so as soon as we are taking a null, so if you go to this very first functionality, so as soon as we are creating a node here, we are keeping on adding the null part automatically. Okay, so we are taking the null part. Okay, so we are taking the null part and we are adding to the very created node, and we are placing that node at the very beginning of the linked list. Okay, so obviously, so whatever the last node will always consist the null part here. Okay, so that's the idea behind that. So and then taking that idea, so we are traversing until the last node here. Okay, so whatever the node we are keep on adding. So if you want to add a node at the very last, the very first, so until that node we are traversing here, and then then if we take an option here, option as at the end. So if we add item 6, it automatically reaches the end of the single linked list by catching the null part in the address section, and then it adds it joins that sixth node or the node which are created newly to that, it erases the null part and then places our address of the new node in that null part, and in turn our now whatever the newly created node becomes the address part of a newly added node becomes the null part. Okay, so if you observe the output once again here, so until now we have traversed until the fifth element, and then we have got the sixth node and added the address of this node to this address part of this node, which consists null by that time, and then we have made explicitly this address part of this node as null here. Okay, so if you observe this statement here inside our added the end functionality. Okay, so main is quite common, which is as we are keep on updating our source code according to the operations we are performing here. Okay, so this is the basic stuff about so how to create a node and add the ending of the linked list. Okay, so hope you will like this tutorial. Place your comments in the form of feedback in YouTube, which is highly appreciable. So see you in the next lesson. Goodbye.